So now let's look at what limits are, and let's first take the example of the previous video. So case dealing with the square function. It's f of x is equal to x squared, and there was an interesting condition here such that x squared, if x is an element of real numbers. Of course, that's the case for the function as such, but the interesting conditions that the output would be 0 if x is equal to 2. So we were discussing the relevance of limits here, how the concept of limits can be applied in this particular case. And let us look at the uh, this particular scenario, and of course we know that as let's first deal with the graph. And so of course that's the x-axis and the y-axis, and of course we know that in this particular case we'll be dealing with a parabola. And of course the interesting case is that when we reach 2, actually there's a gap here, and so actually there's no point where 2 can meet. I mean the ordered pair 2 4 is not coming up as far as this particular case is concerned. Now the point is that how is the concept of limits applied here? And for that we have to look at the number line and the real number line, and of course 0. And now this particular line deals with the y values, that's the output values, that is what the function outputs. Of course here we come equals 2, and that's the x values, so it's the input values, the independent variable. And so the point here is that at 2 getting 0, and how is the concept of limits applied here? For that we have to look at what is happening very near to 0. That's the point. So we have to look at what is happening at the point which is very near to 0, and that is at this location is the point of interest here. And now so this is the left hand side. That's the side as we approach 2 from the left. It's right hand side. That is, we are approaching 2 from the right. And let's look at what is happening here. So suppose it's 1.9 squared. I mean you not the point that we ought to have got 4 here, but we are not getting 4. So if it's 1.9 squared, you'll be getting 3.61. If it's now what if we are dealing with let's take let us do it once more to make the whole idea very clear. That is so this number line, and this 0 means there ought to have been 4 here, but the point is that we are only getting 0 because of this particular condition of the function. And this 2, of course this is the x values. So here we are dealing with the x values, that is the input values, which are the variable is of independent nature. This is the y values, that is the output values, what the function does to the input value. So once again, continuing with the discussion, if it's 1.9 squared, you'll be getting 3.61. If it's more nearer nearer to 2, that is, what if it's 1.999 squared? You'll be getting 3.996. So of course you can do it in a calculator, and you can see what is happening. What if it's again very near to 2, that is 1.9999 squared? You'll be getting 3.9996. So you can see that it's 3.999. So it's just very near to 4, but we are not getting 4. That's the key point. That is what is happening at the left hand side when it is very extremely near to 2. What is happening in the right hand side? Let's take 2.1 squared. You'll be getting 4.41. Let us take 2.01. You'll be getting 4.0401. And if we are taking 2.001 whole square, you'll be getting 4.00401. So you can see that as we get clearer nearer and nearer to 2 from the right hand side, you're getting 4, but we are not actually getting 4. Now that's a key point. So what's the point? What's the limit? So that's the important point. That's exactly what we are looking at here. So it simply means that as we reaches very near to as we are reaching very near to this number, and as we are reaching very near to 2, what we are seeing is that we are getting approximately 4, but we never get 4. So that's a key point here. It is so it simply means that 4 is never attained. But values which are extremely near, that is very near to 4, is of course attained. So that's the meaning of limit. So there's a limit from the left hand side, and also there's a limit from the right hand side. Now coming to the most important point, how do you represent it? So the key point is how do you mathematically represent the limit. That's in this particular case, it's the limit. And the interesting point is as the input value reaches 2, and then you have to write the function. What the function is, that is f of x. That you have to write that. That's x squared. And of course the point is when it tends to reach, or its approaches to, it's what happens when the input value is extremely very close to 2. In that case we get a value which is very close to 4. So this is how you represent this particular case, and that's a mathematical expression for this particular case. Thank you.